Hello, welcome naman to another video tutorial about the structural engineering. So it's been a while since I've posted structural video or tutorials na dito sa ating YouTube channel. So welcome back. Okay? So papag-usapan natin when to use a pin support versus a fixed support. So merong isang nagsuggest na sir, gawan naman natin ng topic about the pin support versus the fixed support. So, shout out sa'yo, engineer. Okay? Tulad niya, since nag-start pa lang din yung career ko as a structural designer, naging curious din ako sa topic na to, whether we use a pin support and a fixed support in our RC frame. So, RC frame natin. So, before we start sa topic na to, alamin muna natin what is the difference between the pin support and a fixed support. So a pin support is restraint about the translation in X, Y, and Z axis. So we are not allowing any displacement in X, Y, and Z directions at that node. We all know in a 3D frame, di ba? At each node has 6 degrees of freedom. 6 degrees of freedom, tama? Pero kapag at that node is pin supported, ngayon nagiging 3 degrees of freedom na lang siya. So ang tanging meron lang sa kanya is meron siyang rotation sa X, sa Y, and sa Z, pero wala siyang displacement in X, Y, and Z directions. However, in a fixed supported naman, we are not allowing all the 6 degrees of freedom to rotate or to displace. So, restrain siya sa X, Y, and Z direction, and also sa rotation in the X, Y, and Z direction. So, yun ang pagkakaiba ng pin support and a fixed support. Okay? So, balik tayo sa question, what support conditions will be used in a reinforced concrete structure? So, ano ba talaga? Disclaimer lang, itong mga nakasulat sa presentation na to is nakalap ko lang or nakolek ko lang about different articles. So, naging curious din talaga ako dito when nag-start pa lang yung career ko as a structural designer. So, disclaimer, kapag meron man akong nakalimutan, paki-comment down below na lang kung meron pa kayong mga suggestions na the difference between the fixed and the pin support, or whether when to use a fixed and a pin support in RC frame. Okay? So, according sa mga nabasa kong article, nobody knows what really happens to the foundation when it is buried into the soil until there is some distress in the foundations are observed. So, wala pala talagang nakakaalam what type of support or what conditions ang meron sa pundasyon natin unless meron tayong na-observe na displacement or distress at that specific point in the foundations. So, in other words, the absence of the knowledge of the pedestal and the foundation stiffness, yun yung dahilan bakit hindi alam or nobody knows kung anong ilalagay sa support conditions natin. However, according to the NERF or the Seismic Design Technical Brief number 1, in chapter 4.3, the foundation modeling, base restraint can have a significant effect in the behavior of the moment frame according to the ASCE 7. So, according to the ASCE 7, for purposes of determining the seismic load, it is permitted to consider the structure to be fixed at the base. So, technically, fixed at the base is more close to the reality, di ba? Alternatively, where the foundation flexibility is considered, it shall be in accordance with Section 12 or Chapter 19. Therefore, okay, the engineer has to decide, the engineer daw o si designer, ang magde-decide which most appropriate analytical assumptions for the frame considering its connection details. Okay? Papakita natin, hindi lang pala pin and fixed support ang meron sa ating foundation modeling. Meron tayong sa figure 4.2, letter A, ito yung pin base. Grade beam extended to the adjacent moment frame. And letter C, base supported by springs to simulate the foundation flexibility. And yung D natin is yung fixed base. Yung letter C na to, it is well known na ginagamit sa mga piles natin o pile foundation natin, sa mga pile cap natin. It is derived from the P is equals to K delta, where yung K yung sinusolve natin is P over delta, di ba? Or yung allowable actual load divided by multiply the factor of safety and the allowable settlement. So, ito yung stiffness natin na tinatawag sa ginagamit natin sa pundasyon. And ito naman yung fixed base and the grade beam extended to the moment frame. Okay? So, according to NERF naman, ulit, the Seismic Design Technical Brief, the modeling of the pin restraint at the base of the column, na pinakita sa figure A, is typical for frames that do not extend through floors below grade. So, ibig sabihin, kapag walang mga basement floors pala, it is more likely na a designer will use the pin restraint. So, these assumptions results in the most flexible column-based restraint. The high flexibility lengthens the period of the building, resulting in a smaller calculated base shear but a larger story drift. Kasi, we all know, we all know ang rotation, ang displacement kapag pin support is ganito. Tama po ba? Iyan, ganyan. Kapag pin support tayo. So, ano mangyayari dyan? Mas tatagal yung period ng building mo. Tama? Kapag mas matagal yung period ng building mo, pag mas matagal yung period ng building mo, matagal yung period ng building mo, ibig sabihin, liliit yung design base shear mo. However, yung story drift mo, mas lalaki, okay? Also, the pin restraint at the column bases also simplify the design of the footing. So, when we use the pin support, mas masisimplify o mas mapapadali ang pagdidesign natin ng footing. Okay? Punta tayo sa next. According to the UBC 1997, the design base shear is CV multiplied by importance factor total weight of the building all over the response modification factor and the period. Okay? When maximum design base shear naman is 2.5, CA is the coefficient in acceleration, IW over RT. The minimum is 0.11, CAIW, and for seismic zone 4, okay, for seismic zone 4, meron naman tayong formula na another minimum. So, 0.8Z and VW over R. So, we all know kasi nasa ilalim yung period. So, the greater period, magkakaroon na yan ng less design base shear. So, tingnan natin kung totoo ba talaga na lumalaki ang period when we use a pin support. Okay? Let's try to see a structure model. Okay? When using ETABS 2016, so ang pin support niya, model 1 or translation in X, ang period niya is 1.068 seconds. Okay? 1.068 seconds. While kapag fixed support naman, meron siyang 0.824 seconds. So, lumiit siya. So, lumiit siya ng almost 17 to 18%, diba? So, talagang liliit talaga ang period when using fixed support conditions. Okay. One drawback naman to the pin base condition is that the story drift of the frame, especially the story drift in the lowest story, is more difficult to keep within the code allowable limit. Kasi napansin natin na mas malaki daw pala ang story drift talaga kapag pin supported. Okay? In addition, a pin base may lead to a development of a soft or a weak story. Okay? If the story drift limit is exceeded in the acceptable limit, then a rotational restraint can be increased. Okay? Pag meron na tayong hindi natin mapasa-pasa sa story drift, rotational restraint can be increased. Whether we use yung grade beam, we use yung may fixed stiffness na letter C kanina, and yung fixed support condition na letter D, regardless of which modeling technique is used in the base column, and the supporting footing or grade beam must be designed to detail the resist forces determined by the analysis. Okay? So kapag mahirap papasahin sa story drift, gagamit tayo ng babaguhin natin yung support condition. Hindi na natin gagamitin yung pin. Yun yung isang drawback when using a pin support. Okay? That is one drawback when using pin support. Okay, tingnan naman natin dito sa same model natin na talagang lumalaki yung story drift when using the pin support. So, I'm using the load combo 1.2 plus 0.5 CAID plus F1LL live load plus the orthogonal effect. Okay? Tingin tayo sa node na to. Napapansin nyo na meron siyang displacement in X na 12.362 millimeters. While fixed supported, at that node naman, meron siyang translation in X or displacement in X-axis na 9.078 seconds lang. Millimeters lang. So, talagang mas malaki yung displacement when using a pin support rather than using a fixed support conditions. Okay? So, another one is the soil stresses. When using a pin support, we all know that the stresses in the soil is P over A lang. However, when using a fixed support, papasok na tong P over A plus MY over I plus or equals to P over A plus 6M over BL squared or B squared L. So, papasok na yung actual with bending kasi magkakaroon na tayo ng additional na parameters para mapasa yung ating foundation. So, medyo tedious yung solution when may moment na, di ba? So, yan yung another drawback when using a fixed support naman. Okay? So, in summary, when using a pin support, it will simplicity in the design of footing, less design base shear, however, meron siyang drawback na prone to weak and soft story, large story drift. While using the fixed support, meron siyang drawback naman na foundation is more difficult to design, higher design base shear, pero not prone to weak and soft story, small story drift or mas mapapasa natin siya sa story drift allowable, and much closer to reality. Okay? So, yun lang yung mga nalikon kong information about whether to use a pin or a fixed support. So, you can comment down below kung meron pa kayong nabasa or nalaman na advantages or disadvantage or when to use a pin and a fixed support conditions. Okay? Thank you very much and mabuhay.